Okay, guys, let's look at our last two examples. So in part C, we're going to do our last two examples. We're writing a Maclaurin series for different functions. Okay, directions: find the Maclaurin series for the given function. Remember, we're just going to assume that there is a power series, and we're not going to worry about all these extra terms. We usually just use a few, and then we're going to do the radius of convergence. Okay. All right, so example 3 is, and remember we're going to use this. We write the first few derivatives, evaluate those derivatives when a is 0 or at 0. Okay, then we write those terms out, and then we write it using sigma notation. Okay. All right, so example 3, we have Kosh. Come on, guys, we had to end with Kosh, right? Well, we got one more, but all right, so this is actually not too bad, believe it or not. Okay, so I'm just going to leave that there. That's our first one. Well, we can rewrite. Our first one is 3 Kosh of 2x, okay? The first derivative, write out your derivatives, okay? Now, the derivative of Kosh is sinh of 2x. So I have this 3, but same thing, I got a quantity. So the derivative of that quantity is 2. All right, second derivative. Derivative of sinh is Kosh. Remember, there's no negative sign, which is kind of nice. But I have a quantity, so my constants come down, but then I have to take the derivative of this guy, which is another 2. Okay. Third derivative. Derivative of Kosh is sinh of 2x. My constants stay. And then the derivative, though, of this guy is another 2. Okay, we can do one more. Derivative of sinh is Kosh. Okay, this is just paper. All right, so we've got all this. This is my constant. And then just make sure I have the right number, but then I have to take the derivative of this quantity. The derivative of 2x is 2. Okay, so step 1 is write out some derivatives. Step 2 is then to evaluate it at 0. Well, we usually need a calculator for Kosh, or we have to use our formula, e to the x and all that divided by 2. But there's only one value we know. Now, when we plug in a 0, Kosh, this 0 is not area, or I'm sorry, it's not angle measure, it is area. So I have an area of 0, which puts me right here, and this is literally the only point we know without having to figure it out. This point is 1, 0. Okay, just like the unit circle. Okay, but remember, Kosh and sinh go off this way, and this number here deals with the area. But if it's an area of 0, I'm right here. Okay. All right, so Kosh is the first, sinh is the second. All right, so when I plug in a 0, I'm doing Kosh of 0, which is 1. So this whole thing is 1, so I've got 3 times 1. Okay. Oh, actually, that was the original problem, right? Okay, so let me just rewrite it down here. I don't want it twice. I wrote the original problem twice. I said I wasn't going to, and then I did. Okay, so here's my function. All right, so now I want to do the derivative at 0. Okay, so I plug in 0 here. What is sinh of 0? Sinh of 0, so my area is 0. My sinh is 0. So I really have 3 times 2 times 0, which is 0. Okay. Second derivative, evaluated at 0. So I plug in a 0 here. 2 times 0 is 0. So what is Kosh of 0? Remember, 0 here is the area. My Kosh is the x value, which is 1. So I've got 3 times 2 times 2, and then times 1. Okay. All right, so now I do the third derivative. I put in a 0. Sinh of 0 is 0. So this whole thing is 0 times all this, though, is still going to be 0. Okay, let's do the fourth derivative evaluated at 0. When I plug in a 0 here, 2 times 0 is 0. Cosh of 0 is 1. So I really have this stuff. I really have 3 times and then 4 2's, right? Okay. All right, so now we want to plug it into this. N equals 0 to infinity. F of n evaluated at 0 divided by n factorial, and then times x to the n. All right, so when n is 0, let's go over here. When n is 0, 0 factorial, x to the 0. When this is 0, we're talking about the original function evaluated at 0, and so that is 3. Okay. All right, then when we plug in 1, we're talking about, well, we could do it at the bottom, 1 factorial, x to the first, and then we're talking about the first derivative. So that is 0. Okay, let's plug in our 2 factorial, x squared, second derivative at 0, 3 times, how could I write this? I could write this as 2 squared. Should we do that? 2 squared. Okay. And then plus, where are we at? We're plugging in 3. So we have 3 factorial, x to the third. I plug in a 3 here. I want the third derivative evaluated at 0. Gives me an answer of 0. Plug in a 4 factorial, x to the fourth. I want this top, says I want the fourth derivative evaluated at 0. That's what? 3. And then it is 2 to the fourth power. Okay. Okay, so now this guy, what is this guy going to give me? 0 factorial is 1, so I've got 3 divided by 1. X to the 0 is 1, so I really just have a 3. 0 divided by anything besides 0 is 0. Okay, then I've got this, 3 times 2 squared over 2 factorial x squared. 0 divided by anything besides 0 is 0, times, it doesn't matter because it's 0. Oops, this should say plus. All right, and then this is what? I got 3 times 2 to the fourth over 4 factorial x to the fourth. Okay, could we guess? Do we need, maybe I should change colors because I'm out of that, but I would guess that 5 would get crossed out. And then I'm kind of guessing, see if this makes sense. So 3, and then I would have 2 to the 6th over 6 factorial x to the 6th. Okay, 7 would cross out, and then I would have 8. Okay, so now, where did my markers go? Now we need to come up with a pattern. So now this is kind of like that trig one where some dropped out. So now this is n equals 0, this is n equals 1, this is n equals 2, and this is n equals 3. Okay. So what's the relationship here? 3 to 6, 2 to 4, 1. Do we see how? And notice though, whatever if I can find this relationship, this number's the same, this number's the same, this number's the same. And then I just got a 3 floating out there. Same, floating. Same, with an extra 3. Okay. So 3 times 2 gives me 6. 2 times 2 gives me 4. 1 times 2 gives me 2. So I think we can do our summation from 0 to infinity. We just have to take it times 2. So 2n factorial, x to the 2n. I got this extra 3 always floating out there. And then it would be 2 to the 2n. Okay. Once I got a relationship with that 6, they're all the same. Would that hold up even here? Here, I would plug in a 0, and this, so this would go to 0, but I'm doing factorial, so it's really 1. X to the 0, so that's why there's no x. And then if I plug in a 0 here, I get 2 to the 0, so that guy's gone, and I would still have a 3. Okay. I don't think there's nothing simplifies, so that's my series. Okay, which, this might be pretty darn helpful because we don't know how to evaluate Cosh. This would actually be a great one. So if I want to evaluate Cosh, I could use this instead. I know this looks kind of messy, but this is more than beyond doable than this Cosh. That's kind of cool. I wish if we had more time, we should see, you know, take a look at that. All right, so now let's see the radius of convergence. Oh, that's actually cool. This is a cool one to think about because this one is not the greatest to evaluate. Okay, so we got 2 to the n over 2n factorial x to the 2n. I could maybe make that extra credit, like actually evaluate this and evaluate that and see if you get the same one. And think about this one's probably a lot easier to do, though we have a calculator for this one, right? So it's kind of like trig, I guess, where we have our calculator. All right, so we need to do the ratio test. Ratio test says what? Okay, let's do this so you can see it. The limit as n approaches infinity of 3, and then now be careful here. It's 2, and then 2, and then n plus 1 has to be like that. X to the 2, and then n plus 1, all over 2. Same thing here. This is going to take we got to be careful. Factorial. Okay, and then draw this longer because then we have to do just with the n. 2n x to the 2n over 2n factorial. Okay, so get rid of that guy. All right, let's see how we do it. The limit as n approaches infinity. Okay, it's going to get longer, and then we're going to simplify. So this is going to be 3. This here is going to be what? 2n plus 2. Same thing here. 2n plus 2. Same thing here. This will be 2n plus 2. Okay, so, and then we're going to split it up. So it'll be 2 to the 2n and then 2 squared, x to the 2n, and then x squared, right? All over 2n plus 2 factorial, and then times the reciprocal. Okay, 3 times 2 to the 2n. I'm just taking this reciprocal of this guy, x to the 2n. Okay, so it goes long, then it goes wide, and then we cancel. The 3's are going to cancel. The 2 to the 2n's are going to cancel. The x to the 2n's are going to cancel. I always get nervous because we don't really want to cancel out x's, but we got this guy, so that's good. All right, so how are these going to cancel? I've got that plus 2, so that means all of this is going to go. And then here I'm going to have 2n plus 1, and then I'm going to have 2n plus 2. Okay, so that's all going to go, and that's going to go, and I'm going to have the extra 2 pieces left. All right, okay, so now, what color do I want to use? All right, so now we got the limit as n approaches infinity. That guy's gone. 2 squared, we could change it to 4 if we wanted. If not, we can always go back. We got x squared. Okay, everything's gone there on the bottom. We've got 2n plus 1, and we got 2n plus 2. Okay, we're taking the limit as n goes to infinity. So all of this is going to head towards 0. Technically, we've got x squared, and then the ratio test says this converges when this is less than 1. Okay, so what will x be where this holds true? Everything, right? You can be a 7, I square it, but then I take it times 0, it's going to be less than 1. Okay, no matter what x is, this answer over here is going to be 0, which means every x value is okay. So radius of convergence is infinity. Okay, so it was actually on the other paper, but this is my series, and this is my radius. Okay. Let's see. Okay, I did number that one. Okay, I want to make sure. Okay, last example. Here we go, guys. Okay, this is a little tricky. This one is, I'm not going to lie, this one is a little tricky. All right, let's see if it makes sense. Oh, come on. All right, f of x equals natural log of 1 plus 3x. Okay. All right, so the first step, if we're writing a Maclaurin series in sigma notation, is to, okay, so let me kind of draw a line. We want the first few derivatives. F of x equals, I'm going to move this over. We're going to use every single space for this. Maybe I don't need it. We'll see. F of x equals This is going to stay. Natural log of 1 plus 3 to the x. Okay, the first derivative. All right, now what's the first derivative of this guy? The derivative of ln is 1 over 1 plus 3x. But then I have to take it times the derivative of this guy, which is times 3. Okay, and I'm going to rewrite this. 1 plus 3x to the negative 1, and then times 3. Okay, the second derivative. Now we're going to roll it down, subtract 1. Roll it down, I get a negative 1. 1 plus 3x to the negative 2. I've got this 3, but I have to take the derivative of this quantity. So times 3. Okay. I'm going to leave some of my I'm going to kind of split things up. So I'm going to roll this down, and that gives me a positive 2, right? When I roll this down, this time, just because it's really the negatives and a 1 doesn't really mean a whole lot, I am going to multiply. So I am going to get 2. 1 plus 3x, subtract 1 takes me to negative 3. I've got these guys, but then I still have to take the derivative of this, which is 3. Okay, let's do 4. All right, so now when I roll it down, I'm going to leave it. I'm going to leave it 2 times a negative 3. 1 plus 3 to the x to the negative 4. Roll it down, subtract 1. I have these 3, and then I had to take the derivative of this guy, which is another 3. Okay, let's do a few more. 5. Okay. Now, when I roll this down, I'm going to leave it, but when I roll this down, the 2 negatives will become positive. So I've got 2 times 3 times 4. 1 plus 3x to the negative 5. Roll it down, subtract 1. These guys are going to stay. They're all constants, so they're just going to stay. But then I had to take the derivative of this quantity, so now I have one more. Okay, let's do one more. Roll this down. So I've got 2 times 3 times 4 times 5, and I'm just going to put the negative out here so I make sure that I see it. 1 plus 3x to the negative 6. These all stay, and then I get one more from that derivative. So 1, 2, 3, 4, 5. Why don't I just rewrite this as 3 to the 6? Okay, which now I could go back and write this as 3 to the 5th, 3 to the 4th, okay, if we haven't done that already. All right, I'm running out of some room, so I think I'm going to evaluate them down here. So f of 0, okay? So what happens when I put a 0 in here? When I put a 0 in here, I have 1 plus 0, which is 1. So I have ln of 1. ln of 1 is 0, okay? First derivative evaluated at 0, okay? So I can go either place. Let's go here. If I plug in a 0 here, I really just get 1. 1 to any power is still 1 times 3. So I have a 3. Okay. Second derivative evaluated at 0. So when I plug in a 0, that goes to 0 plus 1 is 1. 1 to any power is still 1. So I've got my negative 1, and we'll write that as 3 squared. So I have negative 1 times 3 squared. All right. Third derivative. Third derivative, I plug in a 0. That gives me 0 plus 1 is 1. To any power is still 1. So I've got this guy 2, and then I've got 3 to the third. So I've got 2, and then I've got 3 to the third. Okay, fourth derivative. Fourth derivative, I plug in a 0. This goes to 1. So I've got this. I'm just going to rewrite this as negative 2 times 3. Okay, so I'm going to keep these different, and then I got 3 to the 4th. Okay. The fifth derivative, I got these, so this goes to 1. So I got 2 times 3 times 4, and then I got 3 to the 5th. Okay, let's do one more. Can we fit it on here? Yep. Let's fit it on here. Don't forget that negative. and then it's 2 times 3 times 4 times 5. What is that? 5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2. This front is a factorial, okay? And then I still have this back here, which is 3 to the 6th. So I got 3 pieces here. I gotta also take into consideration these guys, but keep in mind, I got this piece, okay, and we have to take into consideration that I've got these factorials, and then I also have to worry about the negatives every other time. So I got a lot I got to think about. Okay, so let's see. Let's move this up. Oh, we're out of paper. Okay, so now remember, I don't think we need these anymore. We do need these guys for sure. Okay. And we're doing, what are we doing? The summation n equals 0 to infinity, f of n evaluated at 0 divided by n factorial x to the n. Okay, so, excuse me. Okay, so how are we doing here? Okay, so let's plug in a 0. We get 0 factorial x to the 0, and what is the original function evaluated is 0. Okay, panic for a second. 0 over 0 is a problem, but remember by definition, this is 1. So 0 divided by 1, so that whole term drops out. Okay, plus, we plug in a 1 factorial, x to the first, and then the first derivative evaluated is a 3. Okay, the second, plug in a 2 factorial, x squared, evaluate the second derivative at 0. Okay, so now I've got this -1, and then I've got 3 squared. All right, let's see. Okay, now we do 3 factorial, x to the third, evaluate the third derivative. I've got 2, and then 3 cubed, right? Okay, then we've got the fourth, 4 factorial, x to the fourth. How did I say I was going to write this? Let's start writing this as factorials, right? So this would actually be, this 2 I could write as 2 factorial. This 1 I could write as 1 factorial, okay? All right, so where am I at? I'm at 4, okay. So this I could write as 3, I can't forget the negative. I can write it as 3 factorial. And then I also need a 3 to the 4th. Oh, man. Okay. So let's at least do one more. So we've got 5 factorial, x to the 5th. Now what do I have to sneak in here? Remember, I've got 3 things. This time it is positive. 4, 3, 2, that is 4 factorial. And then I've got, what are we doing, the 5? Then I've got 3 to the 5th. Okay. We can should we put the last one down here? 6 factorial, x to the 6th. I got to take into consideration the negative. 5, 4, 3, 2. So that's 5 factorial. And then I've got a 3 to the 6th. Okay. All right. So, see, is that right? Okay, that looks good. All right. Let's get rid of this for a minute. Okay, so now this is when n is 0. This is when n is 1. This is when n is 2, n is 3, n is 4, n is 5, and n is 6. Okay. Now, these match beautifully. Look, 6, 6, 6, 5, 5, 5, 4, 4, 4, 3, 3, 3, and they're all matching this guy. I really should say 2, 2, 2, 2. Okay, 1, 1, 1. But, and this is a 1 as well, right? Or 1 here, I guess you'd say. But the problem is, this guy drops out. So now, technically, this is supposed to be 0. This is supposed to be 1, because this term is gone. But we can start wherever we like. So for this problem, since this drops out and everything else matches so nicely, we're going to do the summation when n equals 1. because we can start wherever we like. Most of the time we start at 0. But since this guy dropped out, technically I'd have to assign this 0, 1, 2, but I don't, down here, but I don't want to do that because everything matches so beautifully. So I'm just going to start at 1, which is more than fine. So that means then that this is still n factorial. This is now still n, x to the n. All right, and this is 3 to the n. Okay, because we said all these match and they match this. So now notice when this is 6, this is 5. When this is 5, this is 4. When this is 4, this is 3. So I'm running out of room here. Let me rewrite this. All right, let's rewrite this. N equals 1. All right, so we know this is n factorial. We know this is x to the n, and we're okay with 3 to the n. Okay, this is 1 less, so we need n minus 1. No, what am I doing? We need, n minus 1 to the n, right? Why does that look weird? Oh no, we're fine. No, what am I saying? Oh my goodness. N minus 1 factorial, right? Because this is n factorial. This is n minus 1 factorial. Okay, that looks good. All right. And then, so do we see that this is 1 less? So if this is n factorial, this has to be n minus 1 factorial. Okay, and then the last thing we have to take consideration is it alternates. Now, this is the exact opposite. When it's even, it's negative. When it's odd, positive. Even, negative. Odd, positive. So we can either do -1, and then we can either do n plus 1 or n minus 1. It does not really matter. I don't know. Since we did n minus 1, should we do n minus 1 here? It doesn't really matter, right? Because we just have to change it from odd to even. So if it's a 5, and we do -1, that makes it 4. So it'll actually be, when n is 5, it'll actually be positive. When we do 4, we actually really get a 3, and so then it'll be negative. Okay. Okay, so that's it. We're in good shape, guys. The only thing is, we can reduce this. This reduces. Now be careful. This is n minus 1. So, do we have enough room? All right, n equals 1 to infinity, so that's a new part. We've got -1 to the n minus 1, and then how does this is 1 less on top, so we actually have an n on the bottom. 3 to the n, and then depending where you want to put it, x to the n. Okay, that looks good. We got that guy. Beautiful. That's it. Box it. Okay, so a couple different things happening there. Okay, and then we get the pleasure of checking for the radius of convergence. Okay, so let me rewrite that. Summation n equals 1 to infinity, -1 to the n minus 1, 3 to the n, x to the n, all over n. Okay. All right, so now let's ratio test, right? We're on our way, guys. Ratio test. The limit as n approaches infinity. Here we go. So this is going to be -1, and then we got to do +1 and then -1. Okay, 3 to the n plus 1, x to the n plus 1, all over n plus 1, and then divided by just with n. 3 to the n, x to the n, all over n. Okay, and then instead of, how we do it on space, instead of dividing, let's multiply by the reciprocal. Okay, so this is kind of nice. This cancels out, right? And so we have -1 to the n, 3 to the n times 3, x to the n times x. Okay, all over n plus 1. And then times, let's see how we do it. Okay, and then flip this guy over. So this guy would be n. And then we've got -1 to the n, -1 to the -1, 3 to the n, and x to the n. Okay. All right, so now let's see what cancels here. This cancels. 3 to the n cancels. X to the n cancels. This guy here, right, technically, because it's negative, it would go to the top. And then it's ABS, so that guy's gone. So, okay, so let's write, what do we have left? We got a 3, we got an X, we got an N. And then on the bottom, that guy's gone because of ABS, absolute value. And then we have N plus 1. So that simplified a lot, which is beautiful. Do we have enough room? Okay, the limit as n approaches infinity, we could just move the n to the front. Okay, and then we have 3x, like that. This guy, what is this headed to? Remember, the exponents are the same, so it is headed to the lead coefficients, which is 1 over 1. So that's headed to 1, not 0, because my exponents are the same. So it's headed to the lead coefficients. So it's headed to 1. So I've got 3x less than 1. Okay, so that means negative 1 is less than 3x, which is less than 1. Divide both sides by 3, or I should say every part by 3, right? Negative 1/3. We see this is less than x, which is less than 1/3. I'm starting at 0, and I'm going 1/3 this way, and then 1/3 this way. So my radius of convergence is not very much. It is only 1/3 distance. So my x value has to stay in here, but it will work if my x value stays in here. Okay. All right. All right, see how you do? There's a part, there's one more part. So I'm going to stop it just for, it helps so much if I keep it low. And then there is one last video.